Alright guys, welcome to this page of the notes. So what we're going to do here is, now that we've taken care of that first learning target or objective, which was matrix multiplication, and hopefully you've gotten pretty comfortable with the way matrix multiplication works, the second objective was using properties of matrix multiplication to solve just some other types of problems that I've got for you here. So let's just run through them real quick here, some properties of matrix multiplication. There is the associative property of matrix multiplication. Just simply means that when it comes to multiplying matrices, you can group them together however you'd like. And we're familiar with that when it comes to real numbers. Same thing applies here with matrices. The associative property of scalar multiplication. Again, remember K here is a lowercase number, or a lowercase letter, which means that it is not representative of a matrix. It is in fact a scalar. It's just a constant, right? So we're multiplying those matrices by a scalar. And then we have the distributive property for matrix multiplication. And again, it works just like the distributive property for real numbers, except now we're going to be using matrices, and we'll see how these apply here as we get to some example problems. What I really want to point out, and I cannot emphasize this enough, when it comes to matrix multiplication, remember that order matters, all right? If I give you two matrices, A and B, and I ask you to multiply them together, the product of A times B will not be equal to the product of B times A. In fact, we'll see here in a couple of, I'm pretty sure I've got an example problem for us here on the next page or two, where actually I ask you to multiply A times B and we get a product matrix. But if you flip them around and do B times A, actually matrix multiplication is undefined. It's not even possible. You can't do it. So please be very careful. There is not a commutative property for matrix multiplication. The order matters. Very important. So let's go ahead and try a couple more of these. Matrix multiplication, again, I think we're probably getting to the point here where we can do at least these kinds of matrices in our head 2 by 2. So let's go ahead and do that. Row 1, column 1, 3 times 0 is 0. 2 times 4 is 8. 0 plus 8 would be 8. Row 1, column 2, 3 times 6 is going to be 18. 2 times a negative 1 would be a negative 2. 18 plus a negative 2, yeah, 16. Okay, row 2, column 1, negative 1 times 0, awesome, that's 0, easy peasy. 4 times 4 is 16, and 0 plus 16 would be 16. All right, last one, row 2. Column 2, negative 1 times 6 is going to be a minus 6. 4 times a negative 1 would be a minus 4. And negative 6 plus a negative 4 is going to be a minus 10. And again, I know it takes practice. You certainly will get plenty of it on homeworks and quizzes. But hopefully you can get to the point where these 2 by 2 matrices, you'll be able to multiply them together in your head. At least certainly make that a goal of yours, something that you're working toward. Let's go ahead and try a couple more of these. I got a few more here on the next couple of pages. All right, here's another one. We want you guys to multiply these matrices together. So let's go ahead and do that. We'll try and do this one in our head as well. I think we can probably make this work. It'll be good mental math, stretching ourselves a little bit, but we can do this. We got this. We're going to go ahead and do 2 times 0, which is 0. Negative 1 times 3 is going to be a minus 3. 0 times negative 2 would again be 0. So the only thing I've got, I have 0 minus 3 plus 0. I'm just left with a minus 3. That's all there is. Again, I told you guys earlier, hopefully you remember in a previous video, I said we're really going to like it when zeros show up in our matrices. This is the reason why, right? It makes the math much simpler. Let's keep going. 2 times 1 is 2. Negative 1 times 6 is going to be a minus 6. 0 times 1, that's just 0. So what I have is 2 and a negative 6, which leaves me with a minus 4 when I add those together. Let's keep going. 0 times 0, nothing. 3 times 3 is 9. Negative 2 times a negative 2 would be 4. And 9 plus 4 should be 13. 0 times 1, that's 0. 3 times 6, 18, and negative 2 times a negative 1 would be a positive 2. Well, 18 plus 2 is 20. Guys, well done. That is fantastic mental math. Very, very good. Giving your brains an awesome workout. I love it. I love it. Well done. Here we go. Let's try another one. Here's what I'm asking you to do. I've given you matrices A, there it is, matrix B, there it is, matrix C, there it is. I want you to find A times B plus A times C. And hang on a second. Let's work smarter, not harder. Work smarter, not harder. And here's how. This is the distributive property. Let me show you. A times B plus A times C is the same as A times B plus C. All right, see how it's the distributive property in reverse? How did I get this? Well, I get it by distributing A through the parentheses. Well, which of these is going to be easier? Doing matrix multiplication twice and then adding those products together, or doing a sum matrix and then multiplying once? Yeah, this is way easier. Way easier. Hence, work smarter, not harder. Here we go. I need to do B plus C. Well, that's easy. 0 plus 1 is 1. 3 plus 2 is 6. 1 plus 0 is 1. And 4 plus a negative 3 is also going to be a 1. And I'm sorry, hold up. Yikes. I did 3 times 2, which is 6. It's 3 plus 2. I apologize if I freaked you out there for a second. There we go. We got that all fixed up. Now all I need to do, right, because remember, originally they wanted me to do 2 product matrices, and I have simplified that down to, now all I have to do is 1. I just simply need to do 2, 3, negative 1, and 2, multiplied by 1, 5, 1, and 1. Well, first I need to figure out if this is even possible. This is a 2 by 2, this is a 2 by 2, so yes. Yes, I can multiply these guys together, and it's a 2 by 2 matrix, so let's do it in our heads. 2 times 1 is going to be a 2. 3 times 1 is going to be a 3, and 2 plus 3 will be 5. 2 times 5 is 10. 3 times 1 is 3, and 10 plus 3, how about 13? Negative 1 times 1 is a minus 1. 2 times 1 is 2. Negative 1 plus 2. Yeah, that's a positive 1. And let's keep going. You got one more to go here. Negative 1 times 5 is going to be a minus 5. 2 times 1 is going to be 2. Negative 5 plus 2. How about a minus 3? Guys, well done. That is good mental math, and I'm really proud of you. You're working smarter, not harder. We can certainly appreciate that, right? There's no need to put in more effort than is necessary. Go ahead and use those old thinkers there to work smarter, not harder. Save yourself some time. Guys, well done. I'll see you on the next page of the notes. I'll meet you there.